Question 1. Find the value of the shorter side, j, in the diagram below. Leave your answer in exact form. For Pythagoras here, when we find a shorter side, we'll put the letter side out the front squared, and that will equal the bigger side squared minus the smaller side squared. Our letter in this case is j, so it's j squared on the left hand side. Now the bigger side squared is 7 squared. The smaller side squared is 4 squared, and we'll subtract them. So we'll have j squared, 7 squared is 49, and 4 squared is 16. We'll just calculate that out, and we've got j squared equals 33. Now to undo a square, we can square root both sides. So that'll get us a final answer of j equals root 33. We've got to leave it like that because the answer needs to be left in exact form, and that means leaving it as a surd like that, a square root of a number, and not putting it through your calculator and rounding it off. So final answer, j equals root 33. Question 2. Is the triangle below a right-angled triangle? Justify your answer. Now this looks like a right-angled triangle, but let's see. For any right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. That's what Mr. Pythagoras says there. So let's see if that is true. We can restate this rule as a test to see if a triangle is a right angle. So if Pythagoras' theorem works for a triangle and the square on the hypotenuse does equal the sum of the squares on the other two sides, then the triangle must be a right-angled triangle. So let's see how it works here. If we have Mr. Pythagoras working here for this triangle, we will have the hypotenuse squared on the left-hand side, and that will equal one of the shorter sides squared plus another of the shorter sides squared on the right-hand side. If that all pans out so that the left-hand side equals the right-hand side, we'll know that this triangle is in fact a right-angled triangle. So let's see. The hypotenuse squared will be 15 squared. One of the shorter sides squared is 9. The other shorter side squared is 12 squared. So let's see if that pans out when we calculate the left-hand side and the right-hand side. 15 squared is, 225 in a second, but 9 squared is 81, and 12 squared is 144. 15 squared is 225. And that's a true statement. 15 squared is 225, and the right-hand side ended up being 225 as well. So if we can show that the left-hand side equals the right-hand side in these types of questions, we can say that these numbers kind of made mathematical sense when we arranged them according to Pythagoras. So what we've proved there is the triangle is a right-angled triangle because 15 squared equals 12 squared plus 9 squared in this case, and that's what Pythagoras' theorem says about right-angled triangles. Question 3. Is 10, 24 and 26 an example of a Pythagorean triad? Briefly explain your reasoning. Now, a Pythagorean triad, or a Pythagorean triplet, sometimes it's called, is a group of three numbers that obey Pythagoras' theorem. It means that the bigger number, the hypotenuse, should equal one of the shorter sides squared plus another of the shorter sides squared. So let's see if 10, 24 and 26 fits this pattern. So we'll see, 26 squared should equal 24 squared plus 10 squared if these numbers fit the Pythagoras pattern here. So 26 squared, I'm here to tell you, is 676 on the left hand side, and we get 576 from 24 squared, and 10 squared is 100. So on the left hand side we get 676, and the right hand side we get 676 when we calculate that. So we've had the left-hand side equal the right-hand side when we've run it through the Pythagorean pattern here. So those numbers work for Pythagoras. So the answer is, when we're asked, are these numbers an example of a Pythagorean triad? We'd say yes, because 26 squared equals 24 squared plus 10 squared. Question 4 now. What larger number would be needed to join 30 and 40 in order to form a Pythagorean triad? A Pythagorean triad is a group of three numbers that obey Pythagoras' theorem. So we would have a hypotenuse, one of the shorter sides squared, and another shorter side squared. Those two things are equaling each other. Now, we've said in the question what larger number would be needed to join them. So we know that the 30 and the 40 are the shorter sides. So let's have a look. So that larger number that we're looking at is going to be the hypotenuse. So x squared, if we call x the hypotenuse here, should equal 30 squared plus 40 squared if it fits the pattern. So let's see, x squared equals 900 plus 1600 when we square those two out. When we add the right-hand side numbers together, we get 2500. To work backwards to find out what x should be, we will square root both sides. So x will equal square root of 2500. And when we type that into our calculator, we discover that the number that works for Pythagoras here is 50. So the number 50 would be needed to go with 30 and 40 to make one of those Pythagorean triads. Question 5. Find the perimeter of this shape to the nearest whole number. Now this looks like an impossible task, because for perimeter we need the distance around a shape, and we've got one of the sides missing. Let's see how we can work it out using Pythagoras though. If we find the missing side here, we've got a dotted line that we can make here, creating a bit of a right angle triangle on that right hand side. So that can be a right angle there that we've created. Now if we compare the 40 along the base and the 30 along the top there, we can, well, firstly we'll transfer the height across. So if the left hand side of that rectangle is 26, then the height will be 26. But now we'll compare the 30 and the 40. And I think you can see there, if we take up 30 out of the 40, we'll have 10 of them left. So I'm going to move that 40 across and break it up into the 30 that's down from the top and the 10 that will obviously be created on the base of the triangle. So we've been able to sort of sort out a height and a base for the triangle we're working with here. And we'll use Pythagoras now to find out the distance d that was missing. So we'll use the Pythagoras arrangement. Hypotenuse squared equals one of the shorter sides squared plus another shorter side squared. Our hypotenuse in this case is our d. So d squared is going to equal 10 squared plus our 26 squared that we figured out was the dimensions of our right angle triangle here. So if we process that through, we get d squared equals 10 squared, which is 100, plus 26 squared, which is 676. Let's add that right hand side together and get d squared equals 776. To get d on its own from a d squared, we'll do the opposite to both sides. We'll square root both sides. We get an answer there of square root of 776 for d. If we type that into our calculator, we'll get 28 meters. We'll just round that off to the nearest whole number like the question asked us to. 28 meters for d. So we've got d is 28 meters. And now for perimeter, we need to add up all the way around. So we've got a 30, a 26, a 40 across the bottom in total, and a 28 that we figured out for the hypotenuse of the little triangle. So when we add all that up, we get a perimeter of 124 meters. Pretty impressive, seeing we had a missing side at the beginning of the question. We still were able to achieve a perimeter answer. Question 6. Find the area of the rectangle below. Okay, this looks tricky because we have a diagonal there of 10 millimeters. We have a base or a length of 8 millimeters, but we don't have a height. So it's going to be hard to find the error if we don't have the height, because so we'll need to find that. If we put a H there to indicate a missing height there, this is a rectangle, so we know there's a 90-degree angle in the bottom left-hand corner there. We'll use Pythagoras and work backwards to find the height. Now it's a shorter side that we're finding. So that'll be the letter squared equals the bigger side squared minus the smaller side squared. We use minus when we're finding a shorter side here. The letter is the h squared. The bigger side squared, and the hypotenuse here is 10, so we'll square that, and we'll subtract the 8 squared. So I've set that up there. H squared is going to equal 100 minus 64 when we calculate those. We'll simplify the right hand side just a little bit more. H squared equals 36. If we square root both sides to go from a h squared to a h, we will get an h, a height of this rectangle of 6 millimeters. So now we've got a base times a height to figure out the area of this rectangle. We work backwards using Pythagoras there because we had a diagonal for our hypotenuse. Okay, so now we just can go ahead and find the area. Area is length times breadth, or length times height there for a rectangle. Our length is 8 and our breadth is 6, or our height is 6. And our area in the end is 48 millimeters squared. We use square units for area, of course. So yeah, long question because we had to find out another missing side there before we found the area of the rectangle. Question 7. Find the height of the tower correct to 2 decimal places. Alrighty, so we've got the height of the tower indicated by h there. We have some sort of cable there, or a bit of a diagonal happening of 32 meters on the red dotted line. And we've got a base of a right angle triangle there of 27 meters. So we can work backwards to find the distance from the bottom of the tower to the top of the tower, otherwise known as the height. And it would be a shorter side of a right angle triangle we're trying to find. So it'll follow this pattern. The letter squared equals the bigger side squared minus the smaller side squared. In this case, we've started off with h squared. Our bigger side squared, you can see, is 32 squared minus the 27 squared. Into our calculator we get 1024 minus 729. That can simplify down to being h squared equals 295. To undo a square so we get the final just simple h there, we'll have to square root both sides. So square root of 295 ends up being a height of 17.18 meters. The question asked us for 2 decimal places, so we'll round that off to 2 decimal places there. And also we've got meters because we're just finding a height there. We don't have to use square units or cubic units on that one. So final height 17.18 meters. Question 8. A 12-meter ladder leans against a vertical wall. The distance from the foot of the ladder to the base of the wall is 5.2 meters. How high up the wall does the ladder reach? Let's get a diagram. We've got a 12-meter ladder leading against a vertical wall. So we've got a right angle triangle sort of made by that shape. It says the distance from the foot of the ladder to the base of the wall is 5.2. So that's kind of like the base of our triangle. And we need to find out how high up the wall the ladder reaches. So let's put a h for the height there. It would be one of the shorter sides we're finding on the right angle triangle. So we'll use this arrangement of the letter squared equaling the bigger side squared minus the smaller side squared. We'll work backwards to find this height. Now h squared equals 12 squared minus 5.2 squared. Into our calculator we get 144 minus 27.04. Simplify that further, we get h squared equals 116.96. And we'll square root both sides to get h on its own. and we'll get square root equals 116.96 square rooted there. So when we do that into our calculator, we get 10.8 meters. We've rounded it off to 1 decimal place. The question didn't say how we should round it off, so we can get to choose there. And we're using meters for our distance, our units there. So 10.8 meters for the height of the distance up the ladder, up the wall that the ladder makes there. Question 9. A rectangular field measures 310 meters by 290 meters. A diagonal fence is to be built from one corner to the opposite corner. How long must the fence be? Correct to 2 decimal places. Here's a field. It's got 310 across one side, 290 across another, and we need to find the length of a diagonal fence between the two corners there. So you can see there's a bit of a right angle triangle. We'll use the fact that for rectangles, opposite sides are equal. So let's think of the top horizontal there as being 310 as well, and we'll set up a Pythagoras situation. So just for Pythagoras there, we'll have the hypotenuse squared equals one of the shorter sides squared plus another shorter side squared. We're finding the hypotenuse in this case, so we'll have a plus between our squareds. So 310 there allows us to have a right angle triangle with 310 and 290, and we're finding the hypotenuse. So d squared, find the diagonal here, we've got d squared equaling 310 squared plus 290 squared. Into our calculator we'll get these two big numbers, and we'll add them together. So we get d squared equaling 180,200. To get d on its own here and solve this little equation, we'll square root both sides and get a final answer of 424.50 meters. We were asked to round it to 2 decimal places. Now just to double check, this is a hypotenuse that we're trying to find, and we're expecting our answer to be definitely larger than our longer of the two shorter sides of 310 there. So if our answer isn't more than 310, we might have done something wrong. But I doubt it, because we're pretty clever and careful, and we try hard in our maths. Question 10. Find the value of y in the diagram to 1 decimal place. Alright, looks like a rectangle here, so we've got an 8 centimeters that can come from the bottom of the diagram up to the top. And also we'll compare the vertical heights here. We've got 16 centimeters going all the way to the top of the rectangle, and apparently 6 centimeters going just up to where the line, the slopey line joins. So that leaves us with 10 centimeters for the top section. I'm not sure my diagram's quite to scale there, but anyway, you get the drift. So we can figure out that section on the triangle there in blue is 10 centimeters. So we've got two sides of a right angle triangle, which is pretty handy for finding the hypotenuse, which is where y is sitting. So this is just a hypotenuse equals one shorter side squared plus another shorter side squared. Our hypotenuse we're going to call y, because that's what we're trying to find in the diagram here. Y squared equals 10 squared plus 8 squared. Now that we've found those two sides by having a good look at the diagram. Y squared equals 100 plus 64, making 164. To get y on its own from a y squared, we need to square root both sides, leaving us with 164 square rooted, 12.8 centimeters if we round it off to 1 decimal place like the question asked us to. So 12.8 there. Did a bit of figuring out of sides, and then we applied Pythagoras to it.